All right, so we said that when compounds form bonds, they either share or exchange electrons, right? It all depends on what the electrons are doing, but there's actually many different types of chemical bonds. And what kind of chemical bond we're going to have depends on what kind of elements we have. And so if we have our handy dandy periodic table, right, in this case with our staircase, everything underneath the staircase is going to be a metal. Right? And then everything above the staircase is going to be a nonmetal. And remember the properties of metals and nonmetals. With metals, our electrons are loosely held. Whereas nonmetals, they have a tight hold on their electrons. And then there also is kind of not everything's necessarily a metal or non-metal. Things around the staircase are often classified as metalloids. And they're just somewhere in between. Most of the time, we can treat them as a metal or a non-metal, depending where they are on the staircase. But as you know, same thing with life, right? It's not black and white. It's not one thing is this, one thing is that. There's always some gray area. So anyways, if we think about the electrons and how tightly they're held and think about the different combinations we can have, we can identify what kind of bonding we have. So for example, if we have two metals combined, they both have loosely held electrons, so none of them really want electrons, and the type of bonding there is metallic. This is often described as a sea of electrons. We'll see an example of that soon. If we have a metal plus a nonmetal, then we have one atom that is tightly holding onto its electrons. The other one is not tightly holding onto its electrons. And so there's going to be a transfer of electrons. And we call that an ionic bond. And then finally, the last combination that you can have is two nonmetals or multiple nonmetals. In this case, none of these atoms want to give up their electrons, so they compromise and they form covalent bonds, which is described as the sharing of electrons. So if you think about it, and if you try to understand, ionization energy and electron affinity, these types of bonding and what they do is quite predictable.